Hi, I'm Randall Heyman, a mathematics academic. Welcome to my Corona Help playlists, where I do quick turnaround videos to help students and educators. So if you'd like me to make a video for you, either comment below any of my videos or drop me an email at coronahelpmathematics@gmail.com. Okay, so today I want to talk about sequences. Now, why do I want to do that? Well, the first thing is I'm working towards the 3 C's in this playlist. The first is continuity of functions, which we talked about in a previous video or two. It relied on open and closed sets, amongst other things. The next thing is compactness, and then completeness. Now, when I was doing this one, I brushed over sequences, so I just wanted to fill it in. We're going to need subsequences going forward, so we better make sure we understand sequences properly. So how does this work? Well, we just have this is the notation that you might see for a sequence. This is basically equal to the sequence A1, A2, A3, etc. And we may have a rule with that. For example, AN equals n squared. So then the sequence is equal to 1, 4, 9, 16, etc. So that's a sequence. Now, one of the interesting things about sequences is, do they converge or do they not converge? So, for example, n greater than 1 with an equals 1 on n, well, that converges. An equals n, that does not converge, and because it goes off to infinity. And you can also get this sort of thing, an equals sine n. That does not converge either, because it just oscillates between -1 and 1. So a key idea in sequences is sequences converging to a limit. And so I'll put up a definition. It's very similar to the idea of convergence of a function, which you may also have seen before. So a sequence an converges to a limit L, and notated an approaches L if given an epsilon greater than 0, there is some n such that whenever n is greater than n, we have this, that the an minus the limit is less than epsilon. Now, if that's not the case, we say that the sequence diverges. So what's the basic idea here? I mean, this is quite an important concept. If you're not sure about this sort of stuff, then you probably should go back before you try and launch into compactness and completeness. Let's take example an 1 on n. If we plotted that, well, we'd have 1 here and 1 here. 1, then we'd have 2, 2. So it goes like this. I might actually just extend this. We'll just go right off as far as we can here. Dot, dot, dot. And the basic idea is that if someone would give me an epsilon, an error tolerance, then I can easily work out, in this case, for this epsilon, then I can easily work out that his let's say n, let's let n equal 3. I can see here that for n greater than 3, we have an minus, well, the limit, it goes to 0. You have to know what the limit is for this, is less than this epsilon. And the challenge is that if someone gives you an epsilon, you have to be able to come up with an n, a big N. So in this case here, I can just see that, so for example, epsilon and n. So if someone gave me an epsilon of a half, well, I could set n at 3, 2 or 3. Probably 3 would work. Now, if someone gave me an epsilon of 1 on 100th, I could set n. Turns out that I can set n at 101, and that would work out. And there's actually a pattern here. So for some epsilon, I'd take 1 on epsilon plus 1, something like that would work. Anyway, do a little bit more work on that if you're not sure about it, because it's an important concept. The other thing that will come up, might come up, and so I'll just mention it in passing, is a sequence an. So this is about bounding. It's bounded. So that's the important word that I'm trying to get across here. If there is an m such that an, the size of an is less than m for all n. I don't think I want to go into too much detail about that. I think that's all I want to say about sequences. If you've got any questions on any of this, by all means, comment me below any of my videos or drop me an email. And the same for anything actually in mathematics. I'm happy to have a look at anything. If I think I can help you, then I'll do a video.